everybody. I'm Alessia Fornoni, Deputy Editor of the Journal of American Society of Nephrology and Professor of Medicine at the University of Miami. And I'm excited to be here today with Dr. Gabriela Espinosa Garcia, Dr. Richard Johnson, and Dr. Luan Truong from the University of Colorado Anschutz Medical Campus School of Medicine. We will be discussing today the article entitled Production of Acetylcholine by Podocytes and its Protection from Kidney Injury in Glomerulonephritis, which was recently accepted for publication by the Journal of American Society of Nephrology. Dr. Espinosa Garcia, can you comment on how your study nicely builds on the existing knowledge related to the resemblance of podocyte to neuronal cells?
Yes, both cells have similar structures and share the expression of several restricted proteins. But now we have shown that the podocyte is able to produce acetylcholine, a neurotransmitter that is produced and is a characteristic of cholinergic neurons. In cholinergic neurons, acetylcholine is released to transmit signals to other cells. And we think that in the kidney, podocytes produce acetylcholine to communicate with other glomerular cells like endothelial cells and non-glomerular cells such as macrophages.
So are endothelial cells and macrophages the cells that you think are the most responsive of this acetylcholine production by podocyte? Do I understand that correctly?
Yes, glomerular endothelial cells and also macrophages.
And what are the consequences of this cell-cell crosstalk through acetylcholine?
Our studies support that the kidney acetylcholine is an endogenous anti-inflammatory and endothelial defensive factor. Acetylcholine is a potent anti-inflammatory mediator, but also regulates angiogenesis through the alpha-7 nicotinic acetylcholine receptor and mediates the release of endothelial nitric oxide by activation of the muscarinic acetylcholine receptor M3-M1. And these three receptors are expressed by glomerular endothelial cells. In this study, we investigated the role of acetylcholine during anti-glomerular basement membrane glomerulonephritis, anti-GBM, a kidney inflammatory model in which there is a reduction of angiogenic factors and decrease of endothelial nitric oxide. In this model, acetylcholine targeted macrophages to prevent the production of pro-inflammatory cytokines and chemokines, protecting kidney from inflammatory damage. In addition, acetylcholine attenuated the reduction of angiogenic factors and increased the production of endothelial nitric oxide. Therefore, in this model, the target cells are macrophages and glomerular endothelial cells. However, podocytes, mesangial cells, and glomerular parietal epithelial cells also express muscarinic and nicotinic acetylcholine receptors, and the role of acetylcholine in these cells require more studies.
And do you believe that future studies will reveal that the acetylcholine contribute to the formation of crescent affecting directly the parietal epithelial cells?
Yeah, it's probably, but the crescent formation that is a characteristic of this model of anti-GBM, we found that acetylcholine reduced crescent formation by 98%. So we are proposing that acetylcholine, by protecting the glomerular endothelium and maintaining the integrity of the glomerular capillary wall, can prevent that circulating cells like monocytes and T cells, inflammatory mediators, and plasma proteins pass through the capillary wall and basement membrane into the bone marrow space that will lead to the formation of crescents. In addition, acetylcholine reduces macrophage infiltration that are a key component of glomerular crescents.
Can I add, one comment from my side, Doc? Here is the idea. In crescentic GN, the morphological changes, including changes of extracellular cell, maybe podocyte or parietal cell. There's also a lot of macrophage infiltration. So interesting on theoretical basis, if that acetylcholine improve, it can decrease the damage to both the podocyte and also the macrophage. But interestingly, in our study, we recognize that attenuation is mostly directed at the level of the podocyte, not macrophage. That is something that I would like to emphasize, Doc.
Thank you, Dr. Truong, for making this point. And I agree, it's unique. The finding of this particular publication are unique and have a lot of therapeutic implications, which comes really to my next question. Do you believe that acetylcholine play a role in other vasculitis and other glomerular disease where we have limited treatment options for our patients?
We recognize that acetylcholine is good for the kidney. It is well documented. But the question that everybody is that what cell, that they control acetylcholine is going to be good? Is that tubular cell? Is that podocyte? Is that endothelial cell or infant macrophages? One of the virtue of study, I think, is that we clearly identify that the major target is the podocyte.
Thank you. Dr. Espinosa Garcia, do you want to add your comment about this last question?
Yes, we think that, for example, in ANCA-associated vasculitis, inflammation plays an important role in histopathogenesis. Endothelial nitric oxide production is reduced in this vasculitis, and the presence of macrophages is observed in kidney and vascular tissues. Since acetylcholine reduces inflammation, induces the production of endothelial nitric oxide, and attenuates macrophage infiltration, we think that acetylcholine could provide some protection in other vasculitis. And also, it's important that acetylcholine also targets neutrophils, which play a critical role in these diseases. Acetylcholine inhibits neutrophil infiltration and reduces the production of pro-inflammatory mediators by these cells. And also, I think that it's important that we have now evidence that acetylcholine is protective in podocytopathies, like FSGS. In the adrenomycin model, we have found that acetylcholine reduces proteinuria and preserves podocyte structure.
Amazing. Let me ask one final question to Dr. Johnson. And so what do you believe are the major clinical development and therapeutic implications of this outstanding study?
Well, I think that there are three really exciting things that come out of this study. The first one is that for years, we've always thought of the kidney as having sympathetic nervous system activity, but no cholinergic nervous system activity. As the sympathetic neurons go in, there's no cholinergic neurons. I was taught that the cholinergic system was not important in the kidney. And what we're learning is that there are no cholinergic neurons, but there is a cholinergic system. And that cholinergic system has a lot of effects on kidney disease. So that's the first finding, is that, that's, to me, that's pretty exciting. The second one is that the podocyte is making acetylcholine. And that is really interesting to me, because years ago, Sue Quaggan showed that the podocyte also makes VEGF. And VEGF crosses the basement membrane and keeps the endothelium healthy. And in diseases like preeclampsia, a local VEGF deficiency seems to be important. And so there's a really big crosstalk of the podocyte and the endothelium. And here, Gabriela Garcia has shown that the podocyte is making another factor that has incredible effects on endothelium. When you get nitric oxide vasodilation and so forth, which we know is so important, the primary stimulus that's used is acetylcholine. And so here we have the podocyte making another factor that's keeping the endothelium healthy. I think that's very, very important. And the third, which I think is actually perhaps the most clinically relevant, is that acetylcholine isn't just a vasodilator. It's an anti-inflammatory. It's blocking white cell, macrophage, neutrophil. It's maintaining endothelial integrity. It is an endogenous anti-inflammatory system that can modulate kidney disease. And we are always giving drugs to try to block the immune activation and the injuries that are going on. We're giving anti-inflammatories and immunosuppressants. But what Gabriela has shown, and this has been the thesis of her work, is that there are endogenous anti-inflammatory pathways that might be super important. And actually, I walked away from my desk, but there's a National Geographic that's the title, this cover is Anti-Inflammation. And the fact is that this is an area that just has been understudied in kidney disease and everywhere, the endogenous systems to protect. So to me, I'm just was delighted to be part of this study that was really driven by Gabriela and Luan, because it's like a trifecta. There's three things it does. It explains the neurologic system, the sympathetic and cholinergic. It has more information about podocyte endothelial crosstalk, and it has clinical relevance because of its anti-inflammatory consequences. So that's why I'm excited. Hopefully that's why Jason was excited.
Yes, we were, and thanks a lot to all of you for this outstanding contribution that really advanced significantly the incremental knowledge that we have about the biology of glomerular disease and cellular crosstalk. So congratulations, and looking forward to more productivity from this group on this topic. Thank you all.
Thank you.
Thank you.
You.
This podcast is copyrighted by the American Society of Nephrology. All rights reserved. All content in this podcast is for informational purposes only and is not intended to be medical advice. This podcast should not be used in a medical emergency or for the diagnosis or treatment of any medical condition. Please consult your doctor or other qualified healthcare professional if you have any questions about any medical condition or before taking any drug, changing your diet, or commencing or discontinuing any course of treatment. Thank you for listening to this podcast from the American Society of Nephrology.